I'm Sid, and these are my best friends. My mom, Kim, my dad, Ty, my sister, Maddie, and our salty dog, Stella. We started our adventure refitting a Lagoon 450 before taking on the massive project of resurrecting a sunken 2021 Leopard 50. It's been one heck of a ride, but we're on this adventure to die with memories, not dreams, and live dauntless.
Hey guys, welcome back. We are picking up where we left off last week with wrapping up the major battery installs. And to do that, well, I've got to put some protective covers in, make some mount boards, some switch plates, and what have you. And I've been thinking long and hard on how I'm going to do this. And I really think the difference between an okay install and a good quality install is either knowing how to use your tools to do things they aren't designed for, or getting a tool that will do the job better. I will fully admit that I'm a bit of a tool and I love my tools. That being said, having the right tool for the job, I think, is going to be the key to the success of this project. So a few things that I'm going to be doing or getting prepared to do in the next week or so. I need to make some switch panels that will allow me to put in things like switches and display panels and buttons and things like that. I want it to look nice in the boat, but not everything is going to be easily mounted in plywood. So I'm going to move to a new medium, and that is going to be acrylic. And acrylic is an interesting thing. If it's milled right, it looks very, very professional. And some of the switching and things that I'm going to be putting in, I need 90-degree corners. And I just don't think a jigsaw and some sandpaper really gives you a nice quality cut. So with all that being said, the tool that I'm going to be using this week is actually the sponsor of this video, and that is XTool. And I am going to be taking out of the box a much overdue D1 Pro in their 20-watt version. Now, this laser is a diode laser. It allows you to cut things from wood, leather, acrylic. You can etch and engrave metals and all different kinds of things. And I'm going to be using this and taking it with me on the boat. I think this is going to be a cool piece of kit. Now, it comes in a wide array of strengths and powers. And basically, the higher the wattage of the laser, well, the more things you can cut or the deeper that you can engrave. And because I'm going to be doing some cutting, that is why I chose the 20. So I'm not doing an unboxing video. There's plenty of things on YouTube that you can watch. I will let the camera roll while I put this guy together. And then once I get it put together, I'm going to show you what I intend to use it for, how I do that drawings, and what the end product looks like that I don't think I can produce with any other tool other than a laser. So let's get started. So it all went together pretty well. It took me about 30-40 minutes to assemble everything, go through the quick start guide.
I think it's actually relatively well put together. My only argument with this is that some of these wire looms and the zip ties are kind of cheesy. So I am going to put a drag chain, which is, imagine a bicycle chain that's hollow on the inside, and then you can run wires in it, so it keeps the wires up out of the way, and that will mount actually to the top here. This is not an XTool product. I'm just going to order it off Amazon and put it together. I've seen some other people on other videos do the same thing, and it looks like it's the best solution for the problem. But now that that's done, I'm going to jump off camera here, download the software, and then put it all, get it all set up, and then I will run a couple tests and show you what it looks like.
It's a bit noisy out here, but I'm actually performing my first cut on our laser machine. And this is going to be for this switch panel that I'm putting in for the pre-charge resistor. super freaking cool. I've got air assist running through that's blowing air out the bottom, which I'll show you here in a second. I've got a fan running, and I'm supervising, but I'm not breathing anything in. I've got a enclosure coming that I can actually ventilate all these fumes, and I'll have that assembled soon. But in the meantime...
Begin laser ignition sequence.
Begin laser ignition!
Arm the laser.
Arming the laser!
So I'm jumping in head first here and just gonna go for it and make the cut on the part instead of doing some testing, which I probably should be doing. Now I'm not sure how many passes this is gonna take, but I played around with the settings. Let's try it here. Not quite. So I think we're gonna have to run it again. And I can see that slowly but surely it's cutting through. One piece came out. I think the third time is gonna be the charm on this. All right, guys, it took me a couple passes to get it done, and I'm not sure how clean the edges are going to be, but come over here and look. Check this out. Okay, we're done. Here is our new switch panel.
Whoa, too close.
These little,
You may have to use a punch or something to
yeah, they
get
come
those
out.
guys out.
You can see where some of the paper grabs it, but look at that. All right, so you guys know that I love my Shaper Origin, and it is amazing, and it is good for so many different things. However, this takes it to, I wouldn't say a different level, it's just a different game. You can't do 90-degree corners with a Shaper Origin because it's got a round bit. But check this out. See those sharp corners? I'm able to draw everything in the software that I know and just dump it to the machine. So,
What software is it? This is actually kind of an interesting tidbit.
yeah. So I'm using Shaper Origin software. XTool has their own software as well, which I think you can do the same thing, but I already knew how to do this. And Shaper Origin software just does G-code, so it's XY coordinates, which of course it's two-dimensional cutting. And it worked awesome. So I was able to sketch this up, and probably 15 minutes to sketch it up. Took about 15 to 20 minutes to cut it. It's 1/4 inch acrylic. It exactly, and I mean perfectly, fits. I took the schematics or the measurements off of Blue Sea's website for the switches. I drew it, put it in there, and everything matches. So, 10 out of 10. I absolutely encourage you, if you're going to be doing a project like this, to consider getting one of these. I will put a link in the description, all that. There's a code and all that will save you a little bit of money. But I'm going to be doing a bunch of other stuff like labels and things like that. And for the cost of the machine, I'm telling you what, you're going to do that many projects anyway. And you can, depending on how large the laser is and how thick of stuff you want to cut, you know, you're talking a few $100 up to maybe $800-900 to be able to do exactly what I just did. So I'll show you all the other cool stuff I'm going to do. But until then, it's hot. I'm going to go inside and put all this together, and then I'll show you a picture of what this cool control panel looks like and what it's for. So let's go inside and do that now. All right, guys, welcome to the air conditioning. So I'm very happy with the panel that I cut, and I'm putting all of these bits in here, and this is going to be my pre-charge resistor panel. Now, what is a pre-charge resistor panel? Well, when you have large inverters and they've never been on or they've been off for a while, they need to charge up, so to speak. So there's what's called a capacitor on the inside of an inverter. And if we were to hook up lithium batteries to a big inverter and we just throw the big switch and turn it on, it's called inrush current, is thousands of amps rush towards the inverter trying to fill those up very, very quickly. And the batteries will protect themselves and shut down, but if you do that over and over again, you can cause damage to the batteries and the circuit boards and the capacitors and everything that's in the inverter, and we don't want to do that. Now, there's a couple options. If you buy a Battle-Born battery setup with your Victron Energy inverters, they actually have a big pre-charge resistor deal. I didn't have room for mine, so I'm making my own. And the way I'm going to do that is I am going to have this switch, which I will paint black because it will be the negative DC ground switch for the 48 volt. That is going to mount in this panel like this. So now that we know what the switch is for, how do we let power through this switch? If I turn the switch on without doing anything, well, it's going to shut those inverters and the batteries down. So I want to let power in to the batteries at a small trickle rate, and through that I'm going to use a pre-charge resistor. And that pre-charge resistor looks like this. I'll put it on the screen. That little guy gets wired up through this little push button switch. So when I push this button, it's a momentary, so it only works while I'm holding it down. That lets current run through this pre-charge, and it trickles through all of the small wiring to the inverter. Now, each one of the inverters is going to have one of these little displays, and this display will show voltage. I want to make sure, that's why there's 3 of them, that all 3 inverters are showing the same voltage. And if I don't see any readout, that means that I've blown a fuse. So it's kind of a secondary check system. So I will push this button. Once the button gets pushed, I will wait 10 seconds for the inverters to pre-charge. It's way more time than is necessary, but we just like to put a good cushion on the time that it takes. So I'll hold this, make sure that all 3 of these displays are reading the same voltage, and then after my 10 count, I'm going to release the button and turn the big switch, and that'll power it up.
Is the shuttle launching? No, a camera is turning off, but not this camera, so keep going.
Then we will have AC power in the boat. So that's the way it works.
And Bob's your uncle.
And Bob's your uncle.
Wait, he actually is my uncle.
He is her uncle. So I'm going to put this all together and show you what it looks like, and then we're going to go to the boat. I'm going to install it, and I'm going to turn it on so you can see what it looks like. So let's go do that.
Go.
All right, now I have this temp together. I need to build a bracket to hold this off the wall. That's what these 6 holes are that you see. So I'm going to go take the shaper origin, and I'm going to cut some plywood, and this is going to be the mount structure for this. Then I need to run to the boat, get my tap and die set, because I've got to drill the back of the acrylic and put a tap in for a couple of these little screws to hold this in place. And I'll wire the rest of it at the boat and show you how the whole thing goes together. So I think I've done all I can do in the air conditioning. Now I've got to get out in the heat. Last thing that I forgot to mention was I need to build a support for this pre-charge resistor panel. And I'm going to do that, originally I was going to do it out of plywood, but I'm out of 1/2-inch plywood. So I'm going to do it out of solid stock. I've got some of this solid beechwood left over, and it's 1/2 inch thick, 13 millimeters, and I'm going to cut this with the CNC, and then once I've got that done, then I'll be able to get it pre-drilled and take it to the boat and install it. So real quick before I leave, I'm going to do this, and then we're going to head on over to the boat, install the pre-charge resistor circuit. I'll show you a little closer how that works and give more of a technical description in process. Alright guys, as promised from last week, we're putting all of our acrylic stuff in, and I figured I'd start at the top and work my way down. I had made 2 covers to cover my 48 volt bus bars. However, I made a critical error as I measured the size that I wanted to cover it, but didn't take into account the height that the cover was going to be. So I'll show you that here in just a second. That's a mistake, so I'm going to have to figure that one out again. And then one of our viewers, and I apologize for not remembering your name off the top of my head, but I'll put you down here below me in the video. They made a statement that said, or had a question, as it were, that said, hey, I see you putting all these pocket hole screws in, and they're a different color. Why aren't you using stainless? Well, here's the reason. Well, I didn't know they made those stainless screws. And the last time I bought these Craig pocket hole screws, their only outdoor version was an epoxy coated zinc, which is what I installed. Those are the blue screws you saw me put in last week. But before I said, well, they don't make them that way, I thought, well, maybe I should check to see if they make a stainless one. Maybe I missed something. Well, I looked it up, and lo and behold, they make stainless steel screws now, and I'm super excited about that. So thank you for the tip. I wouldn't even have thought about it. I just would have moved forward, but in trying to give you the right answer, I did some more research and I found something that I didn't know existed. So thank you. Oh, I ordered a box of 100 of them, and I'm going to take all of these screws out, the blue ones, and I'm going to replace them with the stainless ones. So what I'll do with the other 5,000 screws that I bought for the blue, I don't know, but for now, at least I have the right thing. So Now on to my bus bar debacle. So if you want to come on down here and see. So this piece of material here is the same width as this right here. And I was originally intending on this sliding underneath, because as you can see, if I just, it's almost touches, it's like the perfect height, these standoffs. And I thought I was going to be able to get back underneath it there, but as you see, I dropped this down to gain us a little bit more space up top here to store some charts. So what I've got to do is one of two things: either cut this off and move this post back, which I may do, or I've got some 1/4 inch stuff which I really wanted, but it didn't come in time. This is 1/8 inch, and I may get some 1/4 inch and just go from here to here, screw with shorter standoffs like this into the top of these bus bar holders, and then it'll cover that. I just need to make sure that it clears. So I'm gonna wait till I get back to the Airbnb, take some measurements to see the way that works. But I will have covers on here. I just don't know exactly how I'm gonna do it yet, and well, you know, accidents happen. These standoffs right here, I haven't really talked about these. We use these way back in Colorado in our construction company to do signs and what have you, and I discovered they make little tiny ones. These are stainless tubes. So these are stainless tubes, and inside of the tube is pressed a little nut on the inside, and then you screw it in through the bottom. So just for standoffs, they're more than strong enough to hold these acrylic pieces in place, and I kind of like the way that it looks when it's cut the right way.
That's okay.
All right, let's move on down to the pre-charge resistor. Okay, here is the panel that I cut, and you can see that there's these mount holes. There's 3 sets of them, and I'm going to take these boards that I've got cut, and I'm going to make a mount for it. And I'm going to show you kind of how I've got that mounted. I don't know if you can see underneath it there. I can move this back and forth. I just cut that little notch in it to be able to clear the equipment. So I'm going to put this together and show you how it mounts, and then I'm going to put 1 coat of varnish on it, or 2 coats of varnish on it to protect it, and then we'll go down and screw it in the space, and then I can screw the panel on it. And we are moments, kids, in TV world or YouTube world from actually seeing power come on in this boat. So I'm going to focus you down. You can see what I'm doing. So I don't know what you guys think, but I think that looks pretty sexy. All right, now I'm gonna get it wired up on the back side, and after it's all wired, then I'll explain how it works. The first piece of equipment that I'm going to be mounting is this pre-charge resistor. Now to get it to stick to the back here, I'm going to drill and tap some acrylic. This piece will get glued to the back of the acrylic and give me a mounting surface that will allow me to easily remove or replace this if necessary. So the first thing I'm going to do on this is going to wire in some small sense wires that are going to go to each of the individual inverters. I've got inverter 1, 2, 3, progressively longer cables that'll run over, and these are going to get large ring terminals, and they're going to bolt down over top of the lugs that the main 48 volt power comes in with. And that is just going to give me an idea of what the voltages are while the system's operating. All right, so this is a red switch, and this is going to be the negative switch for the 48 volt system. And I'm using this switch because it's rated for 48 volts. And unfortunately, they
don't make a black switch in this size for 48 volt. So I'm sanding it, and then I'm going to paint it with a black textured, no peel guarantee, and I'll get that put together. As soon as that tacks up and I can handle it, then I'll put it in the switch panel. All right, now I'm going to do this off the boat, obviously, because I don't want spray to be coming in. We need to figure out.
Wind is coming this direction.
I'm going to go over on the other end of the dock where there's no boats. Okay, let's set out the sun and the breeze for the next few. Because it is hotter than Hades, and I'm pretty sure it's going to dry lickety-split. All right, I am back from my painting adventure, and I'm going to peel this plastic off of, or this tape off of here, and then I'm going to be able to wire it into the panel. The cool thing about these switches that I wanted to maintain the labels on them is they do glow in the dark. So if you have any lighting in there and the lights go out, you're still able to see, which is pretty cool. Guys, I'm going to argue that that's almost professional. Look at that. Looks good. All right, so now I can mount it in the panel. All right, so the switch is now installed. There we go. And I am going to do a quick recap on this. All right, so what is a pre-charge resistor? This is what I was talking about before. If you buy an inverter from Battleborn, for example, they have these units fabricated, and you will connect your negative terminals from your battery to your inverter through this. And this piece of equipment here acts as this pre-charge resistor and slowly fills up those inverters. I just didn't have room for all of these, and you need one for each inverter. So in my case, I built what you guys have seen me wrestling with the last couple days, and that's this guy. I'm going to show you the backside, and hopefully this will make sense, and I'll make it as concise as possible. But we want to allow a little bit of electricity to go through, and we want it to go through at a certain rate to be able to fill those guys up. So the way that works is this. This is the input side, so from the battery, this will be the DC negative that will connect to the battery. This goes to the bus bar. So when I connect this little wire right here to this, that means that there is essentially 1/2 of the 48 volt circuit is running up to the to this side of the switch. Now when I push this button, and only when I hold the button, it then allows that current to run through here into this resistor. After it runs through the resistor, comes out the bottom and will hook to this side, which is the bus bar. So if you can imagine, when I push this button, it's basically going to complete the circuit, but only the electricity that can flow through this resistor is going to flow through the entire system, and that will slowly fill up all 3 of these inverters. Now this is a large resistor. This guy is, if I remember, 100 watts at 500 ohms. So I'm still going to hold this button for 10 seconds. Once that's done and I turn the switch to on, it then will close this circuit, and the 48 volt batteries will be completely hooked up to the bus bars, and it will be hooked up to the inverters. These 3 displays will just verify for me that I've got adequate voltage to all the inverters and they're all the same. So that's super, super important, because if one of these is missing, it means I've blown a fuse. And anytime you hold this button, you'll see voltages, or when the inverters are on. So we just went from 3 of these to 1 of these. That's it. So I'm going to go install this bracket down there. I've got 1 coat of satin on it. It's kind of hard to tell, but I'm going to screw this guy in, and then I'll bolt this to that. We'll wire it up to the inverters and push the green button and turn everything on. All right, so I've got all of the switches off as far as the positives go up at the companionway, and because I've thought of it and I don't want to forget it, I'm going to put my fuse in. This is a 500 amp A&L fuse, and this goes in the shunt, and if there's any overcurrent through the batteries or pulling anything from the distribution side,
this fuse will blow and separate the entire system. There's also one of these in the 12 volt, and I'll install that here in a few minutes, but I'm going to do that before I put my negative switch in. All right, I think that's gonna do it. And now I'll be able to take, whoa! This is the ground. It's going to come from the bus bar. This is the ground that comes from the shunt. This is the feed to the inverters, and I'll have to pull one more that goes from the DC negative up there down to the input side. But both of them are going to connect, and they're going to tie in on the back side of this switch. Well, I don't know exactly how. Maybe like so. But they'll be in there.
All right, you're on.
All right. So, input side and my output side. This comes up from the 48 volt battery bank, and this runs down to the other side of this shunt. So what I'm going to do is just connect these guys right now, and then put my pre-charged resistor cables on top of that before I snug down these nuts. And then after that, I'll be ready to mount it up and just tie my positive and negative sense wires for my voltage meters to each of the individual inverters.
Ooh, slippery.
And I don't want to scratch my newly painted switch before the paint cures, because we're kind of doing this before it's completely cured. So I'm going to protect it. So here's the input. Here's the output. Pre-charge resistor. Leads.
Wow.
That looks pretty fancy. What's this button, Kim? It's the go button.
It's the go. That's why it's green.
It's a go button. All right, so I need to wrestle this for a little bit. I need to get, again, all of these up to these individual connections. So I'm going to step away for a minute. I'm going to get that done, and I'll come back and show you it all connected. And then we're going to fire it up, and I'll show you the way it works.
On.
Okay, all right, the 48 volt positive switch is on, and we're going to start the system up for the first time and bring 48 volt voltage from the batteries into the inverters. Okay, I've got these in charger only mode. Now, of course, there's no shore power plugged in, but I just want to bring AC, or just want to bring direct current from the 48 volt batteries in here and charge up these capacitors and get it ready to be able to plug shore power into. So I'm going to push this button. It's probably going to be about 10 seconds. There's a lot of capacitors in here that have to charge up. And what we should be seeing is, we should be seeing some lights come on here, and we're going to see the voltages run up until it reaches the same status as the 48 volt bank. So are you ready, Kim?
Heart's beating.
Heart's beating?
Yeah.
Is it?
Yeah.
And there we go.
Wow, that didn't even take 10 seconds.
So it just takes seconds, as you see, not even a second for it to come up. But I'm going to leave it for a good solid 10. And then I'm going to let this go. You see how they'll slowly start to dim out. Now watch when I let go. Slowly the voltages drop out. So I'm going to run it up. And everything stabilizes right at 52. I'm going to turn those guys on, and now we have solid voltage. All the inverters have power to them, and we're good to go. Pretty cool, huh?
A solid green on the shunt.
Yep. Now that the capacitors are charged up, I can take this and you might see if I can flip this over and if you can see inverter on. Inverter on. Okay. Isn't that cool? And I can turn this one on. And I can turn this one on. And we have all three inverters are on and ready to output power. Now we're not that exciting yet. There's no wires hooked up to the outbound side. But the cool part is that all of our air conditioning is DC, guys. So I'm going to be able to switch this over to charger only. We'll be able to take power in from outside. It'll run through these Quattros and charge our battery bank, and then we'll be able to pull out of those batteries to be able to run our AC and cool down so we're not melting like this, and hopefully start moving faster on this refit. So super excited. Thanks again so much for joining us. I think this was a big moment for us. I hope that you guys had as much fun with it as we did. But if you haven't, please subscribe if you haven't liked it yet, or you do like it. If you do like it, of course, please hit that like button, and we'll see you guys next week. If you have any questions, make sure to hit us in the comments below. Thanks again, guys.